Okay, so did anyone have any time to look at these things, the exercises overnight? Did anyone look at anything? What did you look at?
Mainly the stuff in the shy book.
Okay. Anyone else?
Solving with P, not Q.
Pardon?
Solving with, you said
P, not Q.
Yeah.
Okay, so did anyone have any problems? Maybe that's the best place to start. No? Okay, well, what about... We'll start with the exercises from the slides, okay, and then we'll move on to the exercises from the book, okay? Sorry for the late start. I'm not doing very well. Okay, so the exercises from the slides, we had... The bit we didn't do from a linear demand was finding consumer surplus, producer surplus, and deadweight loss. Okay, so we had... So this is slightly tricky. We had P equals P0 minus P1 Q and C equals C0 plus C1 Q. Okay, and in the lectures we went through this and we found that under monopoly, the monopolist optimal choice Q star was P0 minus C1 divided by 2 P1. Okay, so question is, in this case, what's producer surplus, consumer surplus, and deadweight loss? Okay, I gave you kind of rough idea of how you do this. So the first thing to do is to draw these curves on the graph. Okay, so this is price, this is quantity. Here's P0. Okay. Remember, P is equal to 0 when this thing is equal to 0. Okay, so P equals 0, well that implies that P0 minus P1Q equals 0, which implies Q equals, put this one over to that side, and then divide by P1, so Q equals P0 divided by P1. So this is telling us the point at which the inverse demand curve is going to cut the axis, right? So this curve is going down, the demand curve is downward sloping, we know that. At the point at which it cuts the axis, the price is equal to 0. That's what it means to cut the axis. And we've shown that if the price is equal to 0, then the quantity is equal to P0 over P1. Okay, so this curve cuts the axis over here at P0 over P1. So that's a start. We can now draw our straight line. We also need the marginal cost curve, which is very easy. Okay, so marginal cost, this is total cost, remember, C. So when you differentiate total cost, you get marginal cost. Marginal cost is just C1. Okay, so here's C1. So this triangle, this is the maximum amount of welfare that society could gain in this world. Under perfect competition, social planning would say price equal to marginal cost, and total welfare would be this big triangle. Okay, so let's start out by something easy. Let's work out the area of that big triangle. So this side of the triangle, how long is this line? Yeah, exactly. So P0 minus C1. Okay, so let me write under perfect competition, welfare equals P0 minus C1. I remember away. So that's this length of the triangle. What about this side of the triangle? That's a bit harder. How are we going to find that length? Yeah, so there are two ways you could do it. One is kind of the geometric way, is to use the fact that these are similar triangles. the easier algebraic way to do it is a similar approach to the way we found this point. Okay, so we found this quantity by looking for the quantity at which price was equal to 0. This quantity here, okay, this is the quantity at which price is equal to C1. So all you do is plug in C1 equals P0 minus P1 cubed, right? And this is going to give you exactly what we found yesterday, namely that Q equals P0 minus C1 over P1. Okay, so this point here we know is P0 minus C1 over P1. Okay, so welfare under perfect competition is this length times this length divided by 2. That's the area of the triangle, half base times height. So P0 minus C1 times another P0 minus C1. So P0 minus C1 squared, all divided by P1, and then we have to divide by 2 because it's a triangle, not a square. So all divided by 2P1. So under perfect competition, this is welfare. Okay? So this is the most we could get. What about under monopoly? Well, under monopoly, price is determined. The monopolist is going to set marginal revenue equal marginal cost. Here's our marginal revenue line. Monopolists are going to set some Q star. Okay. So Q star we found earlier, this thing is P0 minus C1 divided by 2P1. At that point, there's going to be some price the monopolist is setting. Okay. So what's the price corresponding to this quantity? Quiet. Is it because I'm asking you questions but they're too easy and you just haven't bothered to open your mouth? So all we've got to do is substitute the quantity into the demand curve. Okay, so the price that the monopolist is setting is going to be P0 minus P1 times this thing, P0 minus C1 over 2P1. Okay. And this is going to simplify a bit. We've got a P1 here, we've got a P1 there, so those cancel out. Steps. Okay, so what's this thing? Cancel out the P1s. So this is P0 minus C1 divided by 2. Okay, well we can simplify this a bit more. You can think of P0 as 2P0 divided by 2P0. Okay, so this is 2P0 minus P0 minus C1, all divided by 2. Okay, 2P0 minus P0 is just P0, minus minus makes a plus, so this is P0 plus C1 divided by 2. Okay. P0 plus C1 divided by 2. You said you'd solved for the problem with price setting. Is this the answer you got?
Yeah.
Yeah?
Yeah.
Okay. And it makes sense, right? The price is increasing in the marginal cost. It's increasing in this kind of valuation term. Okay, so we found this point on the graph now. So this is P0 plus C1 divided by 2. Just checking everything's right. Okay, so now we can work out, we've got everything we need to work out consumer surplus. So consumer surplus, remember this is consumer surplus, this is producer surplus, this is dead weight loss. So consumer surplus is this triangle up here. This length is P0 minus P0 plus C1 over 2. Okay, so this is going to be P0 minus C1 over 2. Right? So CS, so something like space on the board, is P0 minus C1 over 2, that's this length. Okay, all times this length, okay, which is the quantity the monopolist is producing, which is P0 minus C1 over 2P1. And then all multiplied by half, because it's a triangle, not a square. Okay, so consumer surplus is going to be P0 minus C1 all squared divided by 2, 4, 8 P1. 8 P1. So there's our consumer surplus. So the consumers do well when marginal costs are low. When marginal costs are low, the firm is producing more, and consumers like consuming, so they're happier when the firm is producing more. If P0 is big, then the consumers really value the product. Okay, so they're going to be happier if they really value the product. If P1 is big, that means this slope is very steep. It means just a slight increase. It means they don't actually want that many units of a product, if you like. So if they don't want that many units of a product, they're never going to be so happy from consuming. So this is our consumer surplus. Producer surplus is this box. So you do the same calculation. This point is P0 plus C1 over 2. This point is C1. So the difference between the two is, we go down here to produce the surplus. So we've got plus a half C1 over 2 minus a whole C1. Okay, so this is P0 minus C1 divided by 2. Times the quantity, right, which is this quantity, P0 minus C1 over 2P1. P0 minus C1 over 2P1. And it's a square, not a triangle, so we don't have to divide by 2. Okay, so this is P0 minus C1 all squared divided by 4P1. And finally, deadweight loss. Well, this length of deadweight loss is this quantity here. So we go up here for deadweight loss. Okay. So we've got P0 minus C1 divided by 2. This length times this length, okay, which is P0 minus C1 divided by P1 minus P0 minus C1 over 2P1. Okay, so we've got a whole minus a half, so that's going to give us a half. So this is P0 minus C1 over 2P1. And then it's a triangle, so we have to multiply by a half. So deadweight loss is P0 minus C1 all squared over 248 8P1. Okay, so let me draw boxes around the answers. There was deadweight loss. Here was producer surplus. Here, where was it? Here was consumer surplus. Okay, slightly messy. So a little check we should do. We worked out the maximum welfare that was attainable under perfect competition. To start with, these three things should add up to this, if I haven't made any mistakes. So let's just check what they do. So we've got, everything has P0 minus C1 squared on the top. And we've got divided by 8P1 here, we've got divided by 8P1 here, we've got divided by 4P1 there. So an eighth plus an eighth plus a quarter, that adds up to a half. So a half is what we have. So it all works fine. Okay, so you can work out consumer surplus and producer surplus. It's a bit tedious, but you know, this is all high school mathematics, working out the area of triangles. not too difficult. Is everyone happy? It's too easy, isn't it? Did you have the option of doing international trade last semester? Did you do it this semester? So international trade's just gone. So what mathsy modules did you do last semester? You did advanced micro, I suppose.
Macro last semester.
Macro was quite
Micro
maths.
physics.
Oh, okay. Okay, so what else did I ask you today? So we showed for markup pricing with isoelastic demand. We didn't go through monopoly pricing working with the demand curve. Does someone want to volunteer to do that on the board very quickly? It's dangerous looking at me. Come on, somebody volunteer. Okay. So the idea was, suppose we had a demand curve that looked like that. And so profits are going to be price times quantity minus total cost again. Okay, it's very similar. So price times Q0 minus Q1P minus. So cost of producing, the cost is always a function of the quantity. Okay, so remember our cost function was C0 plus C1Q. So in order to work out the quantity, we've got to substitute this thing into there to get our quantity. Okay, so the cost is, so we've got a minus sign from there, and we've got C0 plus C1 times Q. What's Q? Well, Q is this bit. Q0 minus Q1P. Okay. So there's our profits in terms of price now rather than in terms of quantity. So you can always think of monopolists as either choosing prices or choosing quantities. It's not going to make any difference.
Sorry, I probably read the question wrong, but I thought you asked us to use the inverse price, the inverse demand that we had, and change that, because then it wouldn't be that way.
Okay, so you could, if I understand your question, you're saying we've got P equals, so we started with P equals P0 minus P1Q.
Yeah.
And you're saying, well, let's take this, so this is P1Q, what am I doing? Equals P0 minus P, so divide by P1Q equals P0 minus 1 over P1 times P. Is this what you worked with?
Yeah.
Yes.
Yeah.
Okay, so what we're working with is, I haven't made up, no, I can't do those class. Okay, so it's like we have Q0 equals P0 over P1 and Q1 equals 1 over P1. Okay, then the two things are going to be the same. Okay, so we'll do it this way in terms of little q's, and then at the end we'll substitute things back like this and we'll check that we get the same answer. Okay? Does that make sense? Okay, so the monopolist is going to choose prices to maximize this expression. Here it's a bit more cumbersome because we have to substitute quantities into the cost function. So when you've got a cost function that's specified in terms of quantities, it's actually easier to think of monopolists as choosing quantities rather than prices. But we'll get the same answer if we work this way. Okay, so basic differentiation. D pi d. What are we choosing? Price. So this is PQ0 minus Q1P squared. Okay, so when we differentiate it, we get Q naught minus 2 times Q1P. Okay, because this is minus Q1P squared. Okay. We've got a minus C naught, that's just a constant, that drops out when we differentiate. We've got this is a minus C1 Q naught, again that's a constant, drops out when we differentiate. And then we've got a minus makes a plus, Q1 times P, that's going to give us a, C1 times Q1 times P, that's going to give us a plus CQ1. Okay. Plus CQ1. Happy? Then skipping steps a bit. So we want to solve for P. So let's take it over to the other side. 2Q1P is equal to Q naught plus CQ1. So P is equal to Q naught plus CQ1 all divided by 2Q1. Or equivalently, the Q1's cancel, so we can write it as Q naught over 2Q1 plus C over 2. Okay, so if I'd given you a demand curve like this is the price that the monopolist you would have found for the monopolist. Let's just check that it makes sense with what we had before by substituting in these expressions for Q naught in terms of P naught. Okay. So Q naught divided by Q1, that's Q naught divided by Q1, well that's equal to P naught divided by P1, all divided by 1 over P1. Brackets around so it's clearer. So we've got division by P1 on both the top and the bottom. Those things just cancel out. So Q naught over Q1 is just equal to P naught. Okay, so this is P naught over 2 plus C over 2. So P naught plus C over 2. And that's what we found when we substituted in previously. So it doesn't matter whether you work in terms of prices or in terms of quantities, you're going to get the same answer. Okay, so let's move on to the exercises from Oz Shy. Just remind myself which ones I asked you to do. 3, 4, 5, 6. Okay, so have some of you managed to find a copy of this textbook? They've all gone from the library already. You'll have to cooperate and share resources. I guess you have study groups, do you work together? Maybe someone nice who has a copy of the textbook can, take photos of exercises and email round or something. In the long run you can buy it. I don't think it's too expensive. How much is it on Amazon?
It's about 45 or 50 pounds.
£5.
Yeah.
Really? They're outrageous textbooks.
Can I clear the board?
There's only about 3 left. Yeah,
if a lot of you are going to be doing this course, it would make sense to ask the librarian to buy some more copies. So, why doesn't one of you volunteer to email the librarian asking them to buy more copies? And, tell them to CC me if there are any problems. Okay, well, the first few exercises we had were about cost functions. This is pretty marginal. So the exercise gave you a cost function, a production function L equals quantity produced is L plus square root K. Okay, where L is labour input, K is capital input. Things you saw in macro. And it's asking if it exhibits increasing returns to scale, constant returns to scale, or decreasing returns to scale. We didn't really talk about increasing returns to scale in the lecture, but you probably know these terms anyway. I'm just reminding you of this exercise. So, if you double all of the inputs, what happens to the output? Does it double? No. Yes. So it's going to be less than double. If you double the inputs, this is going to increase by square root 2, so this is going to be less than double. So this is decreasing returns to scale. That was the world's easiest question. Okay, the next one was consider the cost function. Okay, cost as a function of Q is F plus CQ. Well, this is exactly the type of cost function we've been working with, right? This is fixed cost and a marginal cost. You know, I was calling it C0 and C1, but it's the same thing. Calculate and plot total cost, average cost, and marginal cost. Maybe someone can shout out what these things are going to be looking like. So here's quantity, here's cost. Okay, so what does total cost, what's that graph going to look like?
It intercepts the C at F
Yeah, exactly.
and Q at F over C.
Well, it's going to be upward sloping because it's a positive, so it's going to look like that. Okay, so total cost is increasing. Average cost. Okay, so average cost is total cost divided by Q. Okay, so that's F plus CQ all divided by Q, average cost. So as Q gets big, as Q, you know, you can think of this as F over Q plus C, right? So as Q gets big, this goes to infinity, this bit goes to 0. So as Q goes to infinity, it's tending to C. But when Q is small, F over C is going to be very big. Okay, and Q is 0, F over C is going to be infinite. So it's going to start out very big, and then it's going to decrease until it gets to C. So it's going to look something like that. Okay, where here is marginal cost of C. What output level is the average cost minimized? You can work that out. Yeah, exactly. So it's only when Q gets to infinity that this gets to marginal cost, which is its minimum. And is this increasing returns to scale, constant returns to scale, or diminishing returns to scale? Increasing or decreasing returns to scale? Say a word, any word. Say a different word. So it's going to be decreasing returns to scale, right? No, what am I talking about? No, sorry. It's, you're right, stuff. It's increasing returns to scale, right? Because your marginal cost is falling. Sorry, you're right, stuff. So, you know, if you double the inputs, how much do you get out? Well, before some of those inputs, if you like, were being wasted in the fixed cost. Okay? So you double the inputs, now kind of a lower share of your total input is going to the fixed cost. So you're actually getting more out proportionally. Does that make sense? Okay, next one. Well, there's some things about cost functions. So it gives you this demand curve, and it's asking about the elasticity. So I actually asked a similar question in the slides, I seem to remember. So let's do the question from the slides rather than the one from the book. So we're not going to do that. We'll do the one from the book, which is a bit interesting. So suppose we've got a demand curve like that. What's the elasticity of that demand curve going to be? We did the elasticity of an isoelastic demand curve in the lecture, but we didn't do the elasticity of linear demand. I mean, you probably saw this a long time ago. So the formula for elasticity, you've seen it a million times in your life, is dq dp p over q. Okay. Have I got that the right way around? I do have to check. Okay, so what's dq over dp? Yeah, minus q1, someone said. And then times p over q, and q is this thing. q0 minus q1 p. So let's do the other way around. Sorry. So it's p over q. Let's substitute out p rather than substituting out q. Okay. So what's p? P is equal to so q minus q0 is equal q1p. So this way around. Okay, we've added that to both sides, we're subtracting q is equal to q0 minus q. Okay, so p is q0 minus q over q1. Let's substitute this in instead. Okay. That's right, isn't it? Okay, so we've got minus q1 times p, which we had here, as q0 minus q divided by q1, all divided by q. Okay, the reason I did it this way around rather than in terms of prices is because elasticity is normally thought of as a function of quantity, not a function of price. Okay, so you normally write the elasticity for a given quantity. So this is quite a funny function. It's not very nicely behaved. We've got a q on the top and a q on the bottom. Suppose we can simplify a little bit. We've got a minus q1 here and a q1 there. So let's just simplify a bit more. So these cancel out, and the minus sign is going to flip. Have I made a mistake somewhere? No? You're looking confused. Minus sign is going to flip these things. So q minus q0 all divided by q. That's a bit nicer, isn't it? Yeah, these are cancelled, those are flip. Okay, so this is 1 minus q0 over q. So remember that Q0 is the highest that quantity ever is. Okay? Quantity is always less than Q0, because Q0 is where it's cutting the excess. Okay, so Q is less than Q0. Q is less than Q0. So this thing's small, this thing's big. This whole thing is going to be bigger than 1. So we've got 1 minus something that's bigger than 1, that's going to be negative. The elasticity is negative. At least that's the right sign, that's a good start. Okay? Or it's maybe easier to see from this expression, right? Q is less than Q0, therefore this bit's negative. So V elasticity is negative. We're happy with that. So when's, for what quantities is it going to be elastic? For what quantities is it going to be inelastic? Okay, so it's elastic when okay, so let's work with minus V elasticity to make our life easier. Right, because elasticities are negative, so minus V elasticity is going to be Q naught over Q minus 1. And it's going to be elastic when this thing is big, when minus eta is big. Okay, so when is this thing bigger than 1? Well, add 1 to both sides. Q naught over Q is bigger than 2. Multiply by Q. So Q naught is bigger than 2Q divided by 2. Q naught over 2 is bigger than Q. Okay, so it's going to be elastic when quantity is small. Okay, in particular when quantity is less than half of the maximum quantity they will ever consume. So if quantity is small enough, then demand is elastic. Okay. Does that make sense? Yeah, okay, well, take the extreme case. Suppose that Q is 0. Okay? When Q is 0, the elasticity is minus infinity. Okay? Because at the point where you're consuming nothing, if the price just drops a tiny bit, you go from consuming nothing to consuming something. And in percentage terms, that's like an infinite percent increase from nothing to something. So V elasticity is going to be very small at that point, very high at that point, and then it's gradually going to decrease. Okay, so it's elastic providing Q is sufficiently small. The next question from the book was about isoelastic demand curves, and it's really very similar to what we went over in the lecture, so let's skip that. And then 5.71. Okay, then I asked you to do some exercises from section 5.7, which were about monopoly. So the first exercise is isoelastic demand, linear costs, what's the monopolist doing, is what we went over in the lecture, basically, so we can skip that, okay? And then question 2. Okay, this is more interesting, so let's do this. Okay, so the question says, consider the market for G jeans, the latest fashion among people in their late 30s. G jeans are sold by a single firm that carries the patent for the design. On the demand side, there are NH positive, high income consumers who are willing to pay a maximum amount of VH for a pair of jeans. Okay, so for NH people, who are prepared to pay anything up to VH. Okay? So these are the rich people, they're prepared to pay up to this valuation VH. Remember, NL people who will pay up to VL. Okay, and unsurprisingly, VH is bigger than VL is bigger than 0. And people only want one pair of jeans. Okay, you're not going to buy multiple pairs of jeans. Okay, the monopolist is constrained to set one price. Okay, the monopolist can't look at you and say, you look like a rich guy, I'm going to charge you more than someone else. Okay. So this is, remember we talked about where demand curves come from? This is kind of a simple example like that. We've got two types of consumers, one with a high valuation, one with a low valuation. It's going to generate an aggregate demand curve. And we can draw that as quantity is price. Okay, so we've got NH guys who are prepared to pay VH. And then on top of that, we've got, this point is going to be NH plus NL. So we're NH original guys, and we're adding another NL people who are prepared to pay up to VL. Does that make sense, where that's coming from? For some reason economists draw graphs the wrong way around. Okay, it makes much more sense if quantity was on this axis and price was on this axis, but everyone does it this way, so that's the way you do it. But you're adding up going this way. Okay, so we've got NH, rich guys, NL, people willing to pay less. And that was the first part of the exercise, drawing that graph. Okay, now the rest of the exercise is asking you to find the monopolist's choice of price. So how would we solve for the monopolist's optimal price in this world? Any ideas? Clearly, we don't have a nice differentiable demand curve here. So taking first order conditions isn't going to help us. Any ideas what to do? Did anyone have a go at this exercise? You said you.
I don't know if I've done this right, but I literally just took the two options, whether it's actually VNH times VH or NH plus NL times VL, and then
Yeah.
it's dependent on which is the larger of the two, so those two.
Yeah, that's the right approach. Okay, so profits here, price times quantity, they have zero costs, it says in the question. So profits are just price times quantity. The monopolist has lots of options about what price they set. If they set a price higher than VH, that's a bit stupid. If you set a price higher than VH, no one's going to buy your product. If you set a price exactly at VH, then all of the high-type consumers are going to buy the product. If you set a price in between, still only the high-type consumers are going to buy your product, but you're making less money because you've set a lower price. So there's no point ever setting a price in this interval. So setting a price here is stupid. Setting a price here is stupid. If you set a price exactly at VL, then all of the low type consumers are going to buy the product, and all of the high type, so you get higher quantity. So that might not be stupid. If you set a price below VL, then again you're only selling to the same consumers, but you're selling the same quantity in total, so you've made less money. So you don't want to set a price in this interval either. So you're either going to set a price of exactly equal to VH or exactly equal to VL. So this is what you were saying. All you have to do then is work out the profits in the two cases, find out which one's higher. Okay, so if you set a price equal to VH, then profits from setting price equal to VH, let's call it chi H, that's going to be VH times quantity at that point, which is NH. If you set a price equal to VL, then your profits are going to be VL times NH plus NL. It doesn't tell us anything else about the parameters. So which of these two things is higher is going to depend on the value of the parameters. Okay, if NL is quite small, imagine NL is pretty tiny compared to NH, then this thing's not really adding much at all, so we're going to have VH times NH compared to VL times NL. Well, VH is higher than VL, so this is going to be higher. But if NL is big enough, if there are lots of low-type consumers, then you'd want to set a price so that you can sell to them as well. So it's going to depend on the values of the parameters, but it makes sense, right? If there are lots of low-type consumers, then you want to sell to them, get some money from selling to them as well. Okay, so this is, an example that you always need to think about monopolists as profit maximizing. Okay, so get away from this marginal revenue equals marginal cost. You have to think about profit maximization. Did I ask you to do question 3? No, if I was 1.2 and 7. Okay, so the last question from the book. It's for someone with a downward sloping demand curve. Okay, price is linear A minus Q, and what have we got? Constant marginal cost. Yeah, so marginal cost equals C in the question, and the government is taxing output. Okay. So there's a tax of $T per unit on each unit of output sold to consumers. So if a monopolist charges a price P, what the consumers are going to pay is P plus T. It's just a per unit tax that the consumer has to pay. Okay, so it's easier to work with the other demand curve. So P is A minus Q, so Q is A minus P. And P here...
Tom, sorry, please stop with us. It's a 5 story.
Okay.